Good afternoon, everyone. I am Alina Dmytriv, and today I would like to tell you about my project Definition the Parts of Speech in Ukrainian Words. The goal of this project is to build an algorithm for morphological analysis of words and determine their belonging to different parts of the Ukrainian language, and also make a dictionary of words during their analysis. System analysis. It was used UML methodology to represent the architecture of this program. There is such diagrams as use case diagram, which represents the relationship between actors and precedents in the system, state diagram, which determines the change in system states over time, and activity diagram, which describes the dynamic aspects of system behavior. Here you can see a use case diagram of the system. There are four actors: user, database VESUM, dictionary of synonyms and common root words, and system database. The database of VESUM is the electronic dictionary of word changes of the Ukrainian language. There is register of lengths, code of words change classes, and rules of word form generation. So, first of all, user enters a word and system checks the correctness of it. Then, system does the morphological analysis, which contains such steps. It decomposes word into syllables and determines words parts, such as prefix, root, suffix, and ending. After that, system identifies for entered word its parts of speech, genus, and form. Moreover, system creates words characteristics. There is number of all letters in the word, also numbers of vowels and consonants and others. In the end, system saves all in the database and displays morphological analysis of the entered word for user as a table. This is a state diagram which shows all states of the system. So, when the program is opened, the first its state is waiting for the entered word. When the word is entered, it changes its state to formation of words characteristic. Then there are such states as decomposition into syllables and definition of parts of word, which follow one another. After dividing words into syllables and their parts, the system gradually passes into such states, defining parts of speech, determining the word's genus, and defining the word's form. It is the end of morphological analysis, so then system goes to the state as saving all in the database and displaying the result as a table. But this is not the end of the program. Then it goes back to the state waiting for the entered word. If the user closes the program, then the program ends. Now you can see here activity diagram. First, there is an activity enter a word. If the entered word is appropriate, then a morphological analysis is performed, and if the entered word is inappropriate, it returns to the activity enter the word. At the end, there is an activity to get the result in a tabular form. After receiving the results, you can immediately exit the program or return to the activity enter the word. Software development tools. It was chosen to develop the program by such tools: to create a graphical interface using TechInter, database in MySQL, and do backend on Python. There also were used such Python libraries as requests, TechInter, and MySQL connector. The developed program is called Morphological Analysis of Ukrainian Words. The program performs morphological analysis of words using a database of words with text VESUM to determine parts of speech, genders, and forms, contains an algorithm for dividing words into syllables and their parts according to the rules of the Ukrainian language, and calculates words characteristics such as the number of all letters, vowels, and consonants, and presence of such two letters, apostrophe and hyphen. Here it is the main window of the program. At the top there is a field for entering a word, and after clicking on the button Find, at the bottom in the table a morphological analysis of the entered word will appear. The table has the following attributes: word, parts of speech, word form, genus, syllables, prefix, root, suffix, ending, the number of letters, vowels, consonants, such two letters, apostrophe, and hyphen. Here is a diagram of the number of correct and incorrect actions performed over 35 words in the program. As we can see, most mistakes were made in determining the root and suffix of the word. About 70% made the correct division of words into syllables. All other elements have about 90% correct definitions. Now it is a diagram of the number of words according to the number of errors. As we can see, most of the considered words have 2 or 3 errors in the morphological analysis that was performed by the program. The number of words with other errors is less than half. At the end, here it is a diagram of the numbers of errors according to the number of considered words from different parts of speech. As we can see, quite a small number of nouns have been considered, but they have the largest number of errors, whereas the number of adjectives, adverbs, and verbs refers equally to their number of errors. This suggests that it is quite difficult to perform morphological analysis for nouns, simply for other words as well. Conclusions. The developed algorithms for morphological analysis written on the basis of the rules of the Ukrainian language contain many inaccuracies, because not all exceptions for many Ukrainian words were taken into account. That is why this program needs improvement. However, this proves that the recognition of the Ukrainian language is a complex process and requires more research. That is why this topic is relevant and has many prospects for further development. Thank you for your attention.